In this class, now I am going to explain you continuity. So before going to start this continuity class, now I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Now let us go to this continuity class. Continuity. Now see the first point of this chapter. See, f of x is a one function. You know, we have infinitely many functions in the mathematics, like inverse functions, logarithmic functions, exponential functions, okay, trigonometric functions, algebraic functions, like we have many more functions. I have taken a function f of x. Now I am going to check whether this function is continuous or not at x equal to a. A is a one real number. Now whether this function is continuous or not at x equal to a. Okay, tell me. When it is continuous at x equal to a means if and only if the limit of the function should be existed, and also this limit of the function is equal to value of the function. This is what? Limit of the function. Limit value of this function. That should be equal to value of the function or functional value at x equal to a. Okay? Then you can say that this function is continuous at x equal to a. Okay? So here what did we learn? Whether this function is continuous or not at x equal to a means how you people have to check. You would have to calculate limit value of this function when x approaches to a. How to evaluate limit value of this function when x approaches to a, you learnt in the limits chapter. There you learnt various method to evaluate limit of this function. Am I right? Okay, this is known to you how to evaluate it. And apart from this, you would have to find functional value, that is value of the function. Okay, so both must be equal. Then you can say that this function is continuous at x equal to a. Okay, now let us go to the second point in this continuity. Now tell me whether the given function f of x is continuous or not in the open interval of a comma b. You know the meaning of open interval of a comma b. A is the lower limit, b is the upper limit of that given interval. So in that interval, this function is continuous or not. How do we check? This function must be continuous at every point which belongs to this interval. Okay? So if this function is continuous at every point which belongs to this interval, then you can say that this function is continuous in that interval. Okay? So from a to b there are infinitely many reals. If you take any real number which belongs to this interval, at that point this function must be continuous. Then only you can comment this function is continuous in this interval a comma b. Next, go to the third point. What is third point? Function will be given to you, that is f of x, and one interval is given to you, closed interval of a comma b. You know the meaning of closed interval and open interval. Okay? Now check whether this function is continuous or not in this closed interval of a comma b. How do we check? So this function must be continuous. F of x must be continuous. F of x must be continuous in open interval of a comma b. And the second point is that function must be right continuous at a. Limit x approaches to a plus f of x, which is equal to f of a. Okay, so this is the first point which has to satisfy. F of x must be continuous in the open interval of a comma b, and a and b are also includes into this interval, no? So now you would have to check right continuity at a, and this function must be left continuous at b. Left continuous means limit x approaches to b minus f of x, which is equal to f of b. Then only you people can comment this function is continuous in this entire interval a to b. Okay, when you have to say this f of x is continuous in this closed interval of a comma b, whenever this function is continuous in the interval a comma b, and also it should be right continuous at a and left continuous at b. Okay, right continuous means right hand limit must be equal to value of the function a. Left hand limit at b must be equal to value of the function at b. Then we can say that this function is continuous in this interval a to b. Right. I hope you have understood these 3 points. Okay, here till now what did we do? We people have checked whether the given function is continuous or not at x equal to a. Next, in the second point, what did we learn? That function is continuous or not in the open interval of a comma b. In the third point, what did we learn? This function is continuous or not in the closed interval of a comma b. Okay. Now, let us go to the discontinuity. Discontinuity. Now, students, tell me, when you people have to say a function is discontinuous, whenever that function is not continuous. If a function is not continuous, then obviously that will be called discontinuous. Okay, so under this discontinuity there are 2 types. One is called removable discontinuity. Removable discontinuity, and the second one is irremovable discontinuity. Irremovable discontinuity. Okay, now let us discuss this removable discontinuity. Later on we go to irremovable discontinuity. Okay, so when a function f of x is discontinuous, whenever that function is not continuous. Okay, if a function is not continuous, then it will be called discontinuous. How many types of discontinuity do we have? 2 types. What are that? Removable discontinuity, irremovable discontinuity. Now let us go to the removable discontinuity. Removable discontinuity. Yes. In this removable discontinuity, okay, limit of the function exists. F of x. This limit of the function exists. You know how to check existence of the limit of a function at x equal to a. There you have to evaluate left hand limit as well as right hand limit. Both must be equal. You learned this concept in the limits chapter. Okay, in this removable discontinuity, limit of the function must be existed, but that existence of the limit value must not be equal to f of a. F of a also may be defined or may not be defined, but if it is defined, both should not be equal, or f of a may not be defined. I hope you have understood. In this removable discontinuity, what will happen? Function will be given to you, point will be given to you. There you would have to evaluate limit of the function. You know this procedure we prepared. Now prepare f of a. Okay, it may be defined, but both may not be equal. Both should not be equal. It is defined, it should be defined, but both should not be equal. Then you can say that limit of the function does not exist at x equal to a. Or sometimes it is defined, but it may not be defined. As per the definition of limit of continuity of a function at x equal to a, what did we learn? This should be defined, this should be defined, both must be equal. But here what is happening? This is defined. In this removable discontinuity, this should be defined. It should be given a real value and it should be given a real value. But both may not be equal. Or sometimes it is defined, but this is not defined. Finally, what we people are observing here? Both are not equal. Here not defined also, both are not equal. Am I right? Hence, what you people can comment continuity of this function at x equal to a? Discontinuous. Okay, now in this removable discontinuity, limit of the function exists only, but it should not be equal to value of the function. Otherwise, it is defined, but this may not be defined. Okay, so under this removable discontinuity, there are two more points. One is called missing point discontinuity. Missing point discontinuity. Missing point discontinuity. And the next one, isolated point discontinuity. Isolated point discontinuity. Okay, so here we have two more types under this removable discontinuity. So now let us discuss this missing point discontinuity and isolated point discontinuity. I explain you along with this one example. In this missing point discontinuity, function will be given to you and point will be given to you. So for example, see students, here x minus 2. In this missing point discontinuity, okay, limit of the function, limit x approaches to a f of x should not be equal to f of a not defined. In this missing point discontinuity, at x equal to a, limit of the function is evaluated. It will be given a real number. But whereas at x equal to a, f of a not defined. Now for example, see, take a function f of x equal to 2 minus x into x cube minus 8 by 2 minus x. Now I am giving you a is equal to 2. A is equal to 2. Now check at 2, this evaluate f of 2. F of 2. When you put x equal to 2 in the denominator, what you people are observing here? Numerator also 2 minus 2. So here what is happening? 8 minus 8. Now 0 by 0. Indeterminate form is getting. Okay, so hence what you people can say, the value of this function at x equal to 2, at x equal to 2, functional value is not defined. Am I right? Right. Now evaluate limit of the function when x equal to 2. limit x approaches to 2. So 2 minus x into x cube minus 8 by x minus 2 minus x. You know how to evaluate limit of this function. On keeping x equal to 2 here, denominator is 0. Hence limit of the function does not exist. But we have to make this function should be attain a real value when x approaches to 2. How do we evaluate? We have various methods now. So here already it is factorized. One common factor is there in the numerator and denominator. Now cancel it, and after cancelling, so substitute x equal to 2 here. So what do we get? 2 cube minus 8. So 0 you will get. 0 is a real value. Hence the limit value of this function when x approaches to 2 is 0. Means here limit of the function is defined. How much you got? 0. But whereas RHS part f of a is not defined. Okay. So what you people can say? This function is missing continuity at x equal to 2, no? At only real value it is not defined. But other real values it is defined only. Because numerator is a polynomial, denominator is a polynomial. It is a rational polynomial function. This rational polynomial function is not continuous at x equal to 2. Except that 2, it is continuous on the entire real number set. Okay. Hence, this is an example for missing point discontinuity. Because it is missing at only one point, at x equal to 2. Hence, it is an example for missing point discontinuity. Okay. Now, let us go to isolated point discontinuity. Isolated point discontinuity. Isolated point discontinuity. Okay, students. Right. Now, in this isolated point discontinuity, limit of the function is existed, but it should not be equal to value of the function. In the earlier one, f of a was not defined, but it is defined only, but both are not equal. Okay? Right. Now, I give you one example. F of x. Now, students, see, take this function. Step x plus step of minus x. Okay? Now, I am asking you, to check this continuity of this function at any real number. Okay? Shall I check at x equal to 3? Now I would like to check continuity of this function at x equal to 3. Now limit x approaches to 3. Okay? Now step x plus step of minus x. Actually, you read this, this step function is not continuous at x equal to 3. But here mixture of steps is given. Limit x approaches to 3, only step function is given means limit of this function does not exist. Because left hand limit if you prepare, you will get 2. Right hand limit for this 3. Both are not equal. Hence, this step function is not continuous at all the integers. Not only 3. Like that you read in the function chapter. But here, step x plus step of minus x is given. Shall I check whose left hand limit at 3? Left hand limit of that given function at x equal to 3. Now find left hand limit. Limit x approaches to 3 minus step x plus step of minus x. Now here 3 minus means how much it can be? 2.999, no? Approximate value of x. Now step of 2.9999 minus 2.99. So this value is 2. And what about this value? Minus 3. Now minus 1 you got. Left hand limit at 3. Now prepare right hand limit. Right hand limit. Limit x approaches to 3 plus. So step x plus step of minus x. How much will it be? So you know this is step function, greatest integer function. So 3.0001. Now what about this? Minus 3.0001. What is the value of this? 3. Now what is the value of this? Minus 4. Minus 1. Both were given same result. Hence this function is continuous at x equal to 3. Then what about functional value? Functional value amma. Put x equal to 3 plus step of minus 3. So greatest integer of 3 is 3 only. Greatest integer of minus 3, 0. Now the value of the function is minus 1. Functional value is 0. Both are not equal. Hence can you comment on the continuity of this function at x equal to 3? It is discontinuous. Okay na students? Right. I hope you have understood this removable discontinuity. Okay, under this removable discontinuity, we read 2 more types. What are those 2 more types? Missing point discontinuity and isolated point discontinuity. In the missing point discontinuity, okay, what did we learn? Only that given function is not continuous at only one point in the entire domain. Means here I took a rational polynomial function. Actually, what is its domain? R minus 3. R minus 2. At 2, that was not defined, no? Okay, actually a function must be continuous in the entire domain. You know how to determine the domain of a function. Okay, if you can able to identify the domain of a function in its entire domain, that function is continuous. Means if you draw the graph of that function, so no break will come in the entire domain. While drawing the graph of the function, if you observe any breakings, so in the breaking points that function is not continuous. Okay, you know greatest integer function graph. So whenever integers are getting in its domain, so at the places that graph of the function is jumping when you move from left to right. So where you are observing the breaking points at integers, so that greatest integer function is not continuous at all integers, like that. Okay, so function means obviously it will have a domain. In its domain, compulsory that function will be continuous. Okay na students? Right. I hope you have understood this removable discontinuity. What did we learn there? Missing point discontinuity and isolated point discontinuity. In the missing point discontinuity, okay, that limit of the function defined, but value of the function not defined. Both are not equal. Hence we said that is not continuous. And whereas isolated point discontinuity, that function limit of the function is existed, that was given a real number, and value of the function also defined, that was given different value. Both are not equal. Hence we said that function is not continuous. Okay, right. Now let us go to second kind of discontinuity, that is irremovable discontinuity. Irremovable discontinuity. Irremovable discontinuity. In this irremovable discontinuity, no need to find a value of the function. Just you would have to evaluate left hand limit and right hand limit. What you have to evaluate? Left hand limit and right hand limit. A can be any real number. Both you have to evaluate. limit x approaches to a plus f of x. Both you have to evaluate. Okay na? So now, okay, not required to prepare value of the function, just you evaluate left hand limit and right hand limit. Okay, right. Now in this irremovable discontinuity there are three types. One is called finite discontinuity. Finite discontinuity. And the second one, infinite discontinuity. Infinite discontinuity. And the third one, oscillatory discontinuity. Oscillatory discontinuity. Okay, we have three models: finite discontinuity, infinite discontinuity, oscillatory discontinuity. Now let us check one by one. So in this finite discontinuity, left hand limit, right hand limit, both should be defined. Okay, under this irremovable discontinuity, there you have three more types. Now what are those three more types? Finite, infinite, oscillatory. So suppose if you see the finite discontinuity, in this finite discontinuity, left hand limit of the function at a is defined and right hand limit of this function at a defined, but both are not equal. Both are not equal. Limit x approaches to a minus f of x not equal to limit x approaches to a plus f of x. Both should not be defined. Sorry, both are defined but both are not equal in the finite discontinuity. Okay, so now shall I give you one example? Now check, see, limit value of this function at x equal to 0. Now shall I find left hand limit? Now left hand limit 0 minus, you know, whenever, so here x is approaching 0 from left side means x is negative, no? So whenever x is negative, here make sure that it should be positive, means here 1 by 1 plus 2 power 1 by x. Now when you write here 0 minus here, now it will become, this will become 0. You know, when x approaches to 0 minus 2 power 1 by x approaches to 0. In the limits chapter you read, when x approaches to 0 minus 2 power 1 by x approaches to 0. If it is 0, 1 by 1 is equal to 1. This is left hand limit at 0. Now if you prepare right hand limit, limit x approaches to 0 plus, means here x is positive, no? Now make sure that power of 2 must be negative. How do you make power of 2 negative? You multiply numerator and denominator with 2 power minus 1 by x. Multiply numerator and denominator with 2 power minus 1 by x. Otherwise 2 power 1 by x take common from the denominator. However, okay, I am multiplying numerator and denominator with 2 power minus 1 by x. Why I am multiplying? To make the power of 2 as negative. So here 2 power minus 1 by x plus 1 you will get. Now go for substitution. So it will be given, here it is positive, no? Now it is negative. You know, this becomes 0, this becomes 0 plus 1. 0 by 1, 0. Now left hand limit 1, right hand limit 0. Both are defined but both are not equal, no? Hence, so limit of this function does not exist. Means it is discontinuous at x equal to 0. You are not required to find a value of the function. Are you getting me, students? Right. Now let us go to the infinite discontinuity. In this infinite discontinuity, in this infinite discontinuity, any at least one of left and right hand limits attains plus or minus infinity. Means, students, in this irremovable discontinuity, I said to you to prepare left hand limit and a right hand limit. So left hand limit or right hand limit, any one or both attains plus or minus infinity. At least one of these two should attain plus or minus infinity. Then that function is discontinuous, and that is called infinite discontinuity. Because, okay, so these are attaining plus or minus infinity, no? We are not getting a real number. Okay, hence this will be called discontinuous. Okay, it comes under infinite discontinuity. Okay, if you want, I can give you one example. Now, let us check. See, f of x equal to cos x by x. Now check whether this function is continuous or not at x equal to 0. At x equal to 0. How do you check, amma? Students, tell me. You know, cos x is a bounded function. So this boundary from -1 to 1. Now divide these three with x. Now for left hand limit of this function, limit x approaches to 0 minus. 0 minus means smaller than 0, no? So smaller than 0. In such case, you have to take this -1 by x. And if you substitute this value, it attains minus infinity. And if you would like to find right hand limit, limit x approaches to 0 plus 1 by x, it attains positive infinity. Positive infinity. What you people are observing? Here, left hand limit is attaining minus infinity, right hand limit is attaining positive infinity. Hence, this is not defined, not continuous. Okay? Right. This is an example for infinite discontinuity. Now let us go to the oscillatory discontinuity. Oscillatory discontinuity. Okay, students? Means here, actually here, I explain you along with one example. F of x equal to sin x. Sin of f of x equal to sin of 1 by x. Okay, students, you know the range of sin x -1 to 1. But here not x, 1 by x is given. So if you observe the graph of this function, so you know domain of this function is a set of real numbers, and whereas range is -1 to +1. -1 to +1. If you draw the graph of this, so here it will fluctuate like this. It continues. But here, when you take this domain value, here this is the range. When you take this domain value, this is the range. When you take this domain value, this is the range. And when you take this domain value, this is the range. Are you getting me? So if you keep on substituting domain values, except to 0, at exactly 0, it is not attaining a range, no, not defined is getting. This function is discontinuous at r minus 0, except to 0, students. Now observe the graph of this function, okay, whose range is oscillating between -1 and 1, number. Whose range is oscillating between -1 and 1, but it is exactly not equal to a particular real number. Okay, now, so hence, okay, you can say that limit of the function is discontinuous. Are you getting me? Here, domain value r minus 0. At 0, this is not defined. But see, students, here what you people are finding? The range of the sine function -1 to 1. But here, we are not predicting exact range value. It is oscillating between -1 and 1. Here we are not in the position to say exact limit of this function in this entire domain. It is fluctuating between the -1 and 1. We are not predicting exact limit value. Hence, this type of functions also comes under discontinuous only, because exact limit value we are not saying. Hence, this is called an example for oscillatory discontinuity. Okay, right. Next, okay, one more point we have here, that is called, okay, single point discontinuity. I explain you along with one example. Okay, that function is continuous at only one point. See, definition of the function. F of x is defining like this. F of x equal to x if x belongs to rational number. F of x equal to minus x if x is not rational. Not rational means irrational. Okay, this is an example for single point continuity means. So in this entire real number set, this function is continuous at only one point. What is that point means? See here, this one and this one, equate both and bring it to the left side. 2x you will get. Now x equal to 0. This is the point where this function is okay, continuous. Except to this point, in the entire real number set, this is discontinuous at everywhere. But where it is continuous? At 0 only. Where it is continuous? At 0. Getting me? This function is continuous at only one point. What is that point? How do you evaluate means? Just to equate these two range values and simplify for x. X you got 0 no? At 0 this is continuous. Okay. Now if you want to find left hand limit at 0, right hand at limit 0. Shall I find at x equal to 0? Left hand limit. What is the formula to find a left hand limit? Limit h approaches to 0. F of a minus h no? Here a value is 0. 0 if you write here. Now limit h approaches to 0. F of minus h. Okay. Minus h means smaller than 0. Smaller than 0. Okay. Now smaller than 0 means which one do you take? This one or this one? So irrational number only no? We cannot say here x value is whether rational or irrational. Smaller than 0. Might be rational or irrational. So wherever if you want to substitute you can. But here suppose if you substitute here. So it becomes minus h. H is approaching 0. Now if in the place of h if you write 0. This becomes 0. Similarly if you find right hand limit. Also you will get 0. Okay. Now functional value. Either you substitute here or 0. 0 only will come. Hence, this function is continuous at only at x equal to 0. Okay, this is an example for single point continuity, which means that function is continuous at only one point in the entire real number set. Shall I give one more example? Now, see here. F of x equal to x if x is a rational number. F of x equal to 1 minus x. If x is not rational, x is not rational. Okay, this is also continuous at only one point. How do you say, how do you identify that point where it is continuous means? You must equate this range value. X equal to 1 minus x. Now bring it to the left side. Now 2x equal to 1. Now x equal to 1 by 2. So at this 1 by 2 only this function is continuous in the entire real number set. Except this point, that function is discontinuous at entire real number set. Okay. So this is the concept of continuity chapter. Thank you, one and all.